This is the energy meter of 132 kV Rajabagan Line 1, that is 105. Okay, bay number 105. So our purpose here is to just verify whether the connection done to this meter, and this is also one way of actually checking or inspecting whether there is any malfunctioning or any fraud in the meter connection. And for that, you just have to just check these two quantities of your voltage and currents. Mean whatever your city, they are giving you the right values or not. So let us verify whether the connection done, actually this is the connection is right, but just to show you like whether the connection has been done as according to the drawing, or according to the right procedure, or according to the right way or not. So we'll just see here. So for this meter, since this is 132 kV feeder, okay, so let us first of all check the voltage. Okay, we will be just checking the voltage. So okay, our primary voltage, if you look at this, we'll just take the bus voltage. Okay, it will be 132. Okay, plus minus 5% will be there, but let us take 132. This is our primary voltage, 132 kV, right? So this is our primary voltage. So our respective because our respective secondary voltage will be 110 volt. Okay, so the CT ratio, the PT ratio, it's how much? If 110, it will be 1.2. Okay, 1.2 will be our PT ratio, CVT ratio or PT ratio. Okay, this is the ratio. Okay, so that means if we are 132 kV in the primary, means 110 volt in the secondary. Okay, so but our meter, we will take only we can take the phase also, but we will just be taking only the phase to earth. This is the phase to phase, all right, and the phase to earth will be divided by √3. Okay, so if I do the calculation, let me take a calculator. So your meter should records a value of I'll just do the calculation. 110 is your phase to phase, and then phase to earth will be divided by √3. Okay, then I'll just, in place of √3, or I can write √3 also, fine, 3 like that. Okay, and it will record, your meter should record, secondary should record a voltage of phase to earth will be around 63.5 volt. Okay, 63.5 volts. So this is the value. It depends. Just our secondary should record, because this is fixed only. I mean, it cannot be like 122 or 140. It will be around 132, 33 or 31, like that. Minimum 131 and 132. It can go to 134 also, but it will be in the secondary. What I mean to tell you, that in the secondary I should be getting around 63.5, or it may be 64, 65 also, depending on the primary voltage. Okay, so let me check from the meter whether I'm getting this much or not. If I'm getting this, that means the connection is correct. But if I'm not getting, that means there is something something wrong with either with the meter or with the connection. So I'll just be checking this. This is actually necessary for inspection also. Okay, I'll just be checking whether the meter has been tampered or not, because tampering is illegal as per the Indian Electricity Act 2003. I'll just be checking. See this current all blinking, that means all of them are online. There is a current. Okay, let us see the voltage. I have just taken for one phase, so I can, for any phase it will be more or less the same. So okay, so our phase voltage, phase to earth is 65. It's very close to our calculated value of 63. That means this is fine. Okay, nothing wrong with the meter, the connection is fine. And then let us take B phase, Y phase. Our B phase is 65.47, because our primary voltage is a little bit on the higher side. That's why we are getting 65.44. okay, and then let us go to B phase to earth. It is 65.65. Why I'm getting this value? Because it's a little on the higher side. It's not 132, maybe 134, like that. Okay, so accordingly our secondary values will be this much. So this is how you have verified for the voltage. I mean, voltage is now done. Okay, for V I'm done. Now my second thing to do is for current. I'll have to verify the current. Okay, so for that, let us first of all see what is the value in the BCU value. What is our value, or what is our we'll see from the meter only then. Okay, let us see from the meter, because BCU is already correct. So we'll see. Let us go back. Current, okay, this is B phase current will be 2.23 and Y phase is 0.232 and R phase is also more or less the same 0.234. okay, let us take this value 0.234 or 0.235, 0.234. okay, let me take 0.234 of R phase. Okay, if this value of R phase is in the meter is 0.234, all right, then I'll have to multiply with the CT ratio. Our CT ratio, for our CT ratio is nothing but 400, okay, for 132 kV. So 0.234 into 400, how much you're getting? Let us do the calculation. Okay, 0.234, if you multiply this with your CT ratio of 400, you are getting 93.6 ampere, okay, in our phase, 93.6 ampere. okay, I'll verify this. I should be getting more or less, I mean it may change but not much, okay, around 93, 94, okay, in our phase current. Let us verify that from our BCU. See that from BCU what is the current. If I get this much, I mean it's verified, there is no tampering of the meter. Okay, we are in BCU now, so let us just go forward. So this is our current, okay, IR. okay, my calculated value comes around 93 and this is 95, okay, more or less, because it keeps changing also. So it's correct, that means I'm getting the right values. Okay, so the meter connection is correct. Okay, this is how you verify the meter. Means somebody who will be inspector of for checking vigilance and all, they'll have to like do this properly. It will be like a cakewalk for them because they used to do like every day. Okay, with calculation. And since I'm already here in this BCU, and just let us like calculate our power also, how much power should be flowing in this particular feeder, because we have got the voltage and the current, and accordingly if the voltage is your bus voltage only, see it's 134, okay, and 95, 94, like that, these are the line currents. Okay, so knowing these parameters, we'll just take one. Your power also will approximately be according to the formula of root 3 into line voltage or your bus voltage into your line current, which are the currents shown here. So let me just calculate. Let me take line current as 95, okay, and I'll take 134 as a bus voltage. So let us just do the calculation. Okay, we'll just calculate the power. The three-phase power will be the formula is root 3 into our line voltage or bus voltage into line current. Okay, so I'll put here root 3 into line voltage is 134 kV. Only the unit, no need to write. It's only thing that we have to understand only. And I'm taking line current from the BCU, which is 94 ampere. Okay, so if I calculate this, how much am I getting? This is, I mean, just to verify that your BCU or your SCADA is reading the correct value or not. So I'll just let us do the calculation again. For this, I'll 134, let me write 134 root 3 also, no problem, I can write like this. And then where is the closing bracket? Okay, no, root 3 closing bracket into bus voltage of 134 into the current, which these are the values that I have taken from BCU, is 94. Okay, and you are getting 21,816, but if I have to express in terms of megawatt, it will be 21.8 megawatt, or roughly you can say 21 megawatt, or roughly you can say 22 megawatt. Okay, so let us again check from the BCU whether it's giving you this much of megawatt or what or not. So let us go and check from the BCU. So your BCU should read 22. Okay, so it's giving you this power. See, this active power of 22.2 megawatt. Something wrong in the, just that they have forgot to, in the setting, in the relay setting, there's a factor of 10 has not been divided in the BCU. It's just the program related things only, otherwise it will be, it's 22, because 223 is a huge power. Maybe I wouldn't need this much power, I mean during daytime, especially nighttime maybe this much, but it's very rare that for now they require this much of megawatt. Okay, so it will be 22. Okay, so this is how you read the BCU. Our BCU is REC 670, and same thing can be done for 220 kV feeders, for 400 also. It's the same formula only. So thank you.